All right. Our next presentation is an application of what you just heard on forest inventory modernization and successes and lessons learned in North Carolina's transition to an ESRI-based solution. Will be given by John Lovette, who is a GIS analyst with the North Carolina Wildlife Resources Commission and has been with that agency since 2020. The co-authors are Chris Jordan, is the Forest Resources Manager, and Casey Phillips, the RASP Officer and Forest Analyst, and have been with the Commission since 2007 and 12, respectively. And Kerry Halligan, who you just heard from, is the Senior Geospatial Architect at Mason, Bruce, and Girard. I believe John is giving the presentation remotely.
All right, can y'all hear me?
Yes.
Perfect. Let me pull the slides up here. All right, thanks y'all. It's been great to hear some of the talks so far today, especially what Georgia DNR shared earlier. Sounds like we're tackling some of the similar problems, but from different perspectives. The challenges that we're facing seem to be nearly ubiquitous, and the variety of solutions here is exciting. As I just said, my name is John Lovette. I'm a GIS analyst with North Carolina Wildlife Resources Commission, and I'm joined by Chris Jordan and Casey Phillips. We'd also like to thank Kerry Halligan and the MB&G team for all of their help here. Quick outline, what we're going over today. We'll do a brief overview of Wildlife Resources Commission and talk about our previous inventory system and some of the challenges we face there, as well as some of the goals that we hope to achieve with the new system. Then we'll talk a little bit about our results to date and some lessons learned, and finally wrap up with some information about extensions of this inventory work. So with that, I'm going to hand it over to Chris Jordan.
So lands allocated to the Wildlife Commission that we manage for wildlife are either owned by the state, fee simple, or leased through a cooperative agreement. So our mission on this, you see, this is our mission on these lands. Wrong way. The lands we manage, I think the main point of this slide are around the 500,000 acres that we manage forest resources on. That encompasses around 10,000 stands. We have approximately 12 foresters responsible for forest management on the ground. Since 2014, we've cruised around 24,000 plots. So our previous inventory solution relied on rugged windowless mobile devices, ArcMap, personal geodatabases. We used T-Cruise and FES for analysis. What kept me awake some nights was this distinct possibility of losing data through machine failure or data corruption. So aging Windows mobile devices unable to transfer data between the mobile and Windows 10, and various other difficulties. So our new system, these are what we wanted to get out of it. And especially with improved data management and collection workflows, that being one of the main drivers. So with that, I'll hand it back to John.
Thanks, Chris. To meet these goals, we opted for this solution that you just heard about from MB&G. Their mobile map and inventory manager software allowed us to use ESRI's cloud environment and our in-house GIS expertise to implement a spatially oriented integrated data model with a well-defined hierarchical stands, plots, and trees relationship. Mobile map and inventory manager are also purpose-built mobile and desktop applications that build on top of ArcGIS Online. The focus here was on moving our data into an integrated data model that could be accessed from anywhere by any of our foresters and could also be easily filtered, exported, and analyzed. Spatial data analysis can be handled quickly with ESRI's desktop applications, and data can be exported into specific formats for analysis in software like TCruise and FVS. Moving to an Android-based solution also meant that we could upgrade our devices to devices that were both larger and easier to manage in the field while also being cheaper. To date, through the 2021 field season, we've cruised approximately 2,000 plots in almost 300 stands. From initial implementation in the summer of 2020, when we started this partnership with MB&G, we've successfully trained 12 foresters and integrated our new data model with extensive legacy data that we really wanted to keep moving forward. The new workflows have created an efficient field data collection and management process, which importantly means happy foresters, especially when they may have extended periods between timber cruises. Within a given year, only about 30% of our foresters' time is spent doing timber cruises. They also spend much of their time handling burns and other habitat management. With the improved data access through the cloud, we have greatly expanded our capabilities to conduct advanced harvest planning and have created customized spatial and tabular export methods to meet a variety of needs within the agency. Additionally, the new system has allowed for increased autonomy for data updates by our foresters. As the GIS analyst, I'm able to provide opportunities for the foresters to do data QC and attribute updates independently, therefore removing an additional step in the data management process. And on a personal note, I started this job in January of 2020 with a lot of GIS experience, but virtually no forestry knowledge. So the nature of the software and its integration with ArcGIS Pro and ESRI's online environment, which I was already very familiar with, made it straightforward for me to step into the data management and analysis roles. As with any new software implementation, we've certainly learned some lessons from this process. First, we opted for 10-inch tablets because more screen real estate seemed better. However, these devices have proven to be a little bulky to manage in the field, especially as handheld devices, but they do work great when used with the chest harness. We've also found, perhaps as expected, that the cloud-based workflows are very reliant on good internet connectivity. The upload and download processes specifically. Some of our regional foresters have very limited broadband availability at their home work sites and have to travel to offices with better connectivity in order to handle larger upload and download tasks with the data before going into the field. We learned that having an in-house GIS specialist also greatly increased the possibilities for customizing data management workflows, automating tasks, integrating other ESRI applications, and making changes to the data model. We also came into this project, as I mentioned, with a substantial amount of legacy data that we wanted to import into the new system and continue to build on. This process consumed a pretty large portion of my time early on and would have required extensive back and forth with MB&G staff had we not been able to handle this legacy data import internally. With the data model, we would also note that additional time should be allotted early in the migration to play with the data model structure. As we continued to roll out the software and train our staff, we went through multiple iterations of the data model, and being able to handle these changes in-house and update data on the fly was another benefit of having internal GIS expertise. Finally, we found it very useful to invest the time early on in training 1 or 2 in-house expert users who could quickly respond to other staff questions and support training, especially as much of our training was handled virtually throughout 2020. Once these in-house advanced users were in place, the vast majority of our issues could be handled through virtual training and online documentation, of which there is plenty, and our time spent with MB&G staff could focus on bigger picture changes and improvements. As we continue to grow our inventory capabilities, we will continue to build on this new system. We will soon add data representing our prescribed burns, timber sales, and threatened and endangered species habitat to our existing stands, plots, and trees data within Inventory Manager and Mobile Map. By adding these new data into our data model, we plan to greatly expand our ability to create useful reports and analysis, much of which can be done with apps like ArcGIS Online Dashboards. We also plan to implement timber sale compliance checklists via Survey 123, which is independent of the Mobile Map and Inventory Manager ecosystem, but can be easily queried and used to update timber sale data using ESRI-hosted Python notebooks. Because all of the data now reside in the ArcGIS online environment, this integration across the platform is relatively straightforward and provides numerous opportunities for growth and analysis. Finally, I'm going to hand it over to Casey Phillips to talk about how this work has improved our ability to forecast forest growth and optimize our forest management.
Thanks, John. So our agency is currently developing a strategic forest management plan that's derived from a stumpage-based linear program and model we're building in Woodstock. And we're going to use that to optimize our agency's wildlife habitat objectives by adjusting the timing and intensity of our timber harvest to create the most advantageous mix of forest structures and compositions across our state-owned game lands, while at the same time maximizing our annual net revenues. So the two primary drivers of that model are the stand level habitat scores in each 5-year period of the model for every managed timber stand in the state, and the annual cash flow generated from the stumpage in the thinning and regeneration harvest. Both of those outputs are derived from the predictions of future forest conditions, our growth and yield based on the outcomes of those of FVS growth and yield models as applied to our current forest inventory, which lives on the Inventory Manager. And I'll get to some more of those specifics in a minute, but this figure demonstrates a few different potential management scenarios. On the left side is a production geared scenario that maximizes the net present value. Cash flows high early on because of the time value of money discounts revenues of those harvests occurring further into the future. The habitat scores recover over time, but cash flow eventually drops below the operational threshold that's needed for the agency. The middle scenario focuses solely on habitat without any kind of stabilizing forces on revenue. And of course, we can meet our habitat objectives this way, but it makes fiscal and operational planning more difficult. And on the right, we have the optimal scenario that has a stabilized cash flow that meets both our habitat and financial objectives for the agency. So let's get back to how the Inventory Manager platform helps us achieve these goals. Like I said before, both revenue and habitat scores are derived from the outputs of these growth and yield models that we apply to our current inventory from Inventory Manager. And we're using FVS for all the growth and yield, which, like Kerry mentioned a little while ago, allows us to calculate a whole bunch of custom metrics for every stand in our model for every period. We combine those custom outputs into a habitat index that we can track that allows us to qualify habitat conditions in the best, good, and poor associations relative to the different groups of focal species based on preferred values for structure and composition of those species that are reported in the literature. Inventory manager gives us the capacity to select specific groups of stands based on timber regime, a prescription, or any other attributes that we feel necessary, and then export those FBS ready initialization files in the form of those SQL databases. And that's the basis of our entire workflow, which you can see here. So just to summarize the workflow and highlight the inventory manager products that are inserted at the very beginning here with the export of the FBS initialization file. That data is then integrated with the corresponding shapefile that's also exported from Inventory Manager once the predicted volumes and habitat conditions are calculated in FBS. And the shapefile has the necessary attributes that our modeling software, Woodstock, needs to associate the yield tables developed from the FBS outputs back to the relevant stands, and then spatially represent the harvest volumes and treatments that are applied at the appropriate time in the model, which is functionally the strategic plan. So the ability to pull the spatial and tabular inventory data simultaneously has allowed us to simplify our data management, and the fact that we can continuously export updated versions of the database definitely allow us to keep our model current. And with that, I think we have a few minutes for questions.